In this tutorial, I'll show you how to model a Thyristor-Controlled three-phase rectifier circuit using Universal Bridge. Okay. Firstly, we need AC voltage source. You will find it under Electrical Specialized Power System and Sources. This is our AC voltage source. Then we need Universal Bridge. Universal Bridge is under Power Electronics. This is our Universal Bridge. Okay, and we need voltage measurement block, and finally we need scope, and under specialized power system power B model. Okay, that's okay. We need another block, pulse generator block. Okay, and that's all. And sorry, we need is three-phase AC voltage source. For that we have to go against sources and you'll find three-phase source. Okay, now I'm setting this value is 415 and our source frequency is 60 Hz. You have to mind it. And let's connect this to our universal bridge, and universal bridge number of base arms will be 3 and power electronics device will be thyristor, as we are dealing with thyristor control rectification or converter. Okay, now click OK, and firstly we need to check the output. For that I'm connecting B as output. After verification we'll add filter to this model. Okay, and for thyristor control rectification we need 6 pulses. Okay, so we have to generate 6 pulse and double click on this pulse, and period will be 1/60 as our AC voltage source frequency is 60 Hz. Okay, pulse rate 5 is okay, and phase delay will be 1/60 asterisk 30° minimum value plus phase delay I'm taking phase D. Okay, D will be firing angle alpha will be okay, and I'm taking as alpha, sorry, I'm taking D, and click OK, and pulse generator 2 will be 90° plus D. Okay, 90° plus D, and thirdly we need we have to add 60°. Okay, and 150° plus D, and then 210 and 270. Okay, and the last one 303. Okay, and we have to declare a D in workspace. I have already done here, like D equals 10. Okay, and we need a max block because we have a single G port for universal bridge, and you will find max as commonly used block, and this is our max block. Okay, and input will be 6. Okay, now connect all the pulse generator block to max, and get. Okay, now run this model. I think something happened here. Sorry, I haven't. You have to divide every time 360. Okay, a mistake. 360 all the get pulses. Okay, Okay, I think it's okay. And reducing stop time as one, and run this model. Okay, that's cool. And you can see the output here. Okay, three phase thyristor control rectification. And when our T or firing angle was 10, and I'm increasing this D equals 30. Okay, and go to our model and then again run it. You can see here. So okay, and this is how you can control your rectification by firing angle alpha, and here I use T. Okay, now add filter to get the smooth output. I'm deleting this, and sorry, I will use LC filter here. For this we need a passive component called series RLC branch. Okay, and this will be our L. L is like 1e minus 2, and then we need a capacitor. Okay, change it to C, and its value like 1e minus 3, and connect it here. Then I'm taking two resistive component, value 100. Okay, now complete our circuit, and I want to measure voltage at this point, and run this model. Now you can see our DC output. Okay, if you reduce this D value here, presently D is 30, I'm taking as D equals 10. Okay, now from scope run this model. Okay, now you can see here. So this is the way you can uh, model or simulate thyristor control rectification using universal bridge. Okay, that's all for today. Thanks for watching.